Now I'll populate the database with the 8 vector layers. And I'll begin by adding the final 2 layers, streams and lakes, to QGIS Desktop. Remember, these are KML files. I'll click the Add Vector Data button and click Browse. And I'll set the filter to KML. And I'll find the 2 lake and stream layers, click Open, and Open to add those to QGIS Desktop. Now I can begin importing all of these data sets into my SpatialLite database. I'll begin by going to the Database menu to the Database Manager. I'll expand the SpatialLite database connection, and I'll expand my Gifford-Pinchot database. Let me make this longer so I can see all the tables in there. And I see there's a lot of tables, but there are no GIS layers yet. Those will have point, line, polygon icons next to them when they're in the database. First, I'll import the streams and lakes into my database. I'll simply click the Import Layer button. Lakes will be the first one I'll use. I have to assign a table name. This will be the name of the layer in the database. I'll just call it Lakes. And I want to check the source SRID. Remember, this data is KML, so it's got a geographic coordinate system with an EPSG code of 4326. And I'm going to click the target SRID until I want it to reproject this data into 26910 UTM Zone 10 on the way into the database. I can always choose to click Create Spatial Index. Some of these layers aren't large, but some are. This will help them render and help queries. And I'll simply click OK when that's done. Import was successful. And now if I click the Refresh button on the Database Manager, I'll see my lakes layer with a polygon icon next to it. I'll do the same for the streams. I'll stick to the same names. Again, give it a source SRID of 4326 and a target SRID of 26910. Click OK. Import was successful. And again, if I click refresh, I'll see the streams layer with the line icon next to it in my database. Those were the final 2 layers that required a CRS reprojection. The remaining 6 UTM layers can now be imported. The only change will be that the input and target SRIDs will be 26910. So I'll start with roads. Click the down arrow. Choose that layer. I'll call it roads. And the source SRID is 26910, as well as the target. Click OK. Import was successful. Click refresh, and now I've got a 3rd layer imported. In the lab, you'll repeat these steps to import the remaining layers, the trails, the watersheds, ranger districts, vegetation, and the forest boundary layer into the database. Now all 8 layers have been imported, and I can see all 8 of them in my database within the Database Manager. Now that that's done, I can remove the layers that I have in my Layers panel, select them all, and choose Remove. And I'll be re-adding the layers from my SQLite database. And there's 2 ways to do this. From the Database Manager, I can right-click on a layer and choose Add to Canvas. So that's my National Forest boundary. So I could also add watersheds in that way. So that's a very simple way to add them. The other way is to use the Add SpatialLite layer. I'll click that, and here I need to choose my database, Gifford-Pinchot, and click Connect to connect to the database. And from there, all the layers in that database show up, and I just select the ones I want to add to my map. So I still need to add lakes, ranger districts, roads, streams, trails, and vegetation. I'll click Add. And now all 8 layers I have in my QGIS project are from my SpatialLite database. This database connection will also be visible in QGIS Browser. So if I bring up Browser and scroll down below my drives to my SpatialLite connections, and click Refresh, I'll see my Gifford-Pinchot SQLite database. If I expand it, I'll see my 8 layers within QGIS Browser. In this lab, we took data in several different file formats, coordinate reference systems, and spatial extents, and normalized them. They're all now in the same CRS, clipped to the forest boundary, and are stored in a spatialite geodatabase. This methodology is the benefit of creating a working copy of the data. The raw data still exist in shapefile and coverage and KML format. Therefore, if you accidentally delete or corrupt a dataset, you'll still have the original to fall back on. Additionally, the data now all reside in a tidy database. Since they're all in the same CRS, you can run any geoprocessing or analysis tools against them, knowing they're all in UTM Zone 10 NAD83.